In question number 81, it is given that if the general solution of a differential equation is y square plus 2cy minus cx plus c square equals to 0, where c is an arbitrary constant, then what is the order of the differential equation? There are four options been given. Fine. So let me first discuss about order of differential equation. Order of a differential equation order of a differential equation is the highest order of derivative that occurs in the differential equation, and also if I talk about degree of a differential equation, then degree of a differential equation is the highest power of the highest order derivative that occurs in the equation. Also, if the equation is rational and radical free. Okay, mind that. Now here we are given with the equation that is y square plus 2cx minus c 2cy minus cx plus c square equals to 0. Let's simplify it. Cy plus c square equals to cx, y plus c whole square equals to cx. Correct? Now we are going to differentiate this expression with respect to x, both the sides, right? So in order to do so, first this expression we will treat it as a polynomial. So let me tell you, if the formula of finding derivative of x to the power n, that is n x to the power n minus 1, and if we differentiate x with respect to x, we will get 1. Correct? So here first we since this is a function of y, but we are differentiating it with respect to x, so we will treat it as a polynomial like y square, so it becomes 2 multiplied by y plus c. Then we will differentiate y. So it becomes dy dx. And if we differentiate a constant, it will give us the value 0. Here also we are differentiating with respect to x. So it will left with c only. With respect to x. Okay. Next. So it becomes, so here dy dx we can denote it as y dash. So it becomes 2y plus c y dash equals to c, or 2y y dash plus 2c y dash equals to c. So here c 1 minus 2y dash 2y y dash. So c becomes 2y y dash by 1 minus 2y dash. Okay, so we have got the value for the constant. Now substituting this in the given equation, substituting this in the given equation, we get y plus c means 2y dash by 1 minus 2y dash whole square equals to y dash 1 minus 2y dash multiplied by x. So inside the bracket we can simplify it. It will become 1 minus 2y dash whole square and y 1 minus 2 plus 2y y dash its whole square, 2xy y dash 1 minus 2 y dash. So both the 1 minus 2 y dash got cancelled. It becomes y minus 2y y dash plus 2y y dash whole square, also 2x y dash 1 minus 2 y dash. Both this part will got cancelled. So it's y square equals to 2x y dash 1 minus y dash, right? So after simplifying, after bringing both bringing the right expression from the right side to left side, it becomes y square minus 2x y dash plus 4x y dash whole square equals to 0. So here, since I have already written that y dash means dy dx, right? So this is first order derivative. So the highest derivative in it is y dash, the first order derivative. The highest derivative in it is y dash. Okay. Therefore its order is 1, since it is a first order derivative, right? And if we try to find the power, highest power of this derivative is 2, because the exponent of y dash, we can see the highest exponent of y dash is 2, so its degree is 2. Though they haven't asked us, but still I'm writing it. The highest power of this derivative in the equation is 2. Therefore, its degree is 2. So now let me check the options. What is the order? Order is 1. So here option A is the correct one. In question number 82, it is given that what is the degree of the following differential equation? Now let's talk about degree and order of a differential equation first. That is, order of a differential equation is the highest order of derivative. So order of a differential equation is the highest order of derivative. Okay, and what about the degree of a differential equation? Now, degree of a differential equation is degree of a differential equation is the highest power power of the highest order of the highest order derivative that occurs in the equation. Okay, and also the derivatives are, after the derivatives are converted into rational and radical free form. Okay, now here the equation is being given x equals to root under 1 plus d2y by dx2. So here we can see there is a square root. First, getting rid of this radicals by we need to square both sides. Okay, so it's given x equals to root under 1 plus d2y dx2. If we square both the sides, we will get x square 1 plus d2y dx2. Okay, so here the highest derivative in it is d2y dx2. Therefore, its order is 2 because it is second order derivative. The highest derivative in it is d2y dx2. So therefore, the order is 2. Now, if we talk about the uh, degree of this derivative, then what is the power of d2y dx2? That is 1. So we can say the degree of this equation is 1. Its degree is, though it's not required for this question, its degree is 1. So let me check that what is the degree. Okay, degree is required, but order is not required. Okay, so since the highest power of this derivative in this equation, the degree of the highest power of this derivative in the equation is 1, so its degree is 1. So it's matches with option A. In question number 83, it is given which one of the following differential equations has the general solution y equals to a e to the power x plus b e to the power minus x. First of all, so let me write the equation a e to the power x plus b e to the power minus x. Next, we will differentiate both the side with respect to x, so it becomes dy dx. Now if we differentiate e to the power x with respect to x, we will get e to the power x back. Fine. And what happened in this case, e to the power minus x? Look, it did ddx e to the power minus x. So first we will differentiate that e to the power minus x. It will give us the same value, e to the power minus x. Now we will check the exponent also. So there is minus x. Now if we differentiate minus x with respect to x, we will get minus 1. So it becomes minus e to the power minus x, correct? So yes, let's apply the same here. To the power minus x, e to the power x minus of b e to the power minus x. Right? Now, again, we are going to differentiate it with respect to x. So ddx of dy dx equals to ddx of a e to the power x minus b e to the power minus x. Now it becomes d2y dx2. This is second order derivative. And here a e to the power x. Now minus of minus b e to the power minus x. So it becomes minus minus plus b to the power b e to the power minus x. Here d2y dx2. So look, this also equals with y. We again got back the y. So we can substitute y here, y d2y dx2 or d2y dx2 minus y equals to 0. So here the correct option is option B. In question number 84, it is given that what is the solution of the following differential equation? Ln dy dx plus y equals to x. First, let me tell you, log is defined for base 10 and ln is defined for base e. Okay, now here the given equation is ln dy dx plus y equals to x. Let's proceed with the calculation. Ln dy dx x minus y or dy dx equals to e to the power x minus y. Now from it we can write e to the power x, e to the power by e to the power y, because a to the power m minus n equals to a to the power m by a to the power n. We got it from the laws of exponents, dy dx. So we can further write it as e to the power y dy dx e to the power x. So if we apply integration both side, we will get dx plus c, where c is the integration constant. So it will give us the value e to the power y equals to e to the power x plus c, right? So here integration of both sides, we get e to the power x minus e to the power y, e to the power x minus e to the power y equals to minus c, or we can say this, if we name it as c1, the constant, if we refer it as c1, so minus c1 can be written, can be referred as another constant, that is c. So yes, it becomes e to the power x minus e to the power y equals to c, which is constant. So here option C is the correct one. In question number 85, it is given that what is integration e to the power 2 ln x plus ln x square dx equals to. So first of all, let me write. Okay, so first let me tell you, log is defined for base 10 and ln is defined for base e. Okay, so the formula for integration x to the power n dx, that is x to the power n plus 1 by n plus 1 plus integration constant plus c. Also, e to the power ln x can be written as only x because it is already defined for the base e. So here we can refer the given expression as I. So let I equals to integration e to the power 2 ln x plus ln x square, that is dx. So here e to the power ln, this become 2 ln x square plus ln x square dx. Like we know log a plus log b can be written as log ab. Okay, so exactly the same way we can write e to the power ln x to the power 4 dx. So e to the power ln x to the power 4 can be written as x to the power 4, reference to this formula. So it becomes x to the power 4 dx. So the answer is 4 plus 1 plus c, where c is the integration constant. So I equals to x to the power 5 by 5 plus c. Let's check the answers. Yes, it matches with option D. In question number 86, the question states that consider the following measures of central tendency for a set of n numbers. Okay, so we need to here discuss about arithmetic mean and geometric mean. Which of the above use or uses all the data? First, let's talk about arithmetic mean. So the arithmetic mean of a set of n numbers, the formula of arithmetic mean is sum of all the observations by total number of observation, right? So the arithmetic mean of a set of n numbers is given by, let's say there are n numbers, am is summation xi by n. That means x1 plus x2 plus x3 dot 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 up to xn, and since there are n observations, so by n. Now what about geometric mean? The geometric mean of a set of n numbers is given by, if say there are n numbers x1 x2 x3 dot 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 up to xn, then we can write, so the product in root product of x1 x2 x3 multiplied by up to dot 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 xn. Okay, now look, both the arithmetic mean and geometric mean use all the data for their calculation. Here also we are adding n numbers, all the data. Here also we are finding the product of all the observations. So they uses all the data. So both 1 and 2, both use all the data. That means option C is the correct one, both 1 and 2. In question number 87, it is given that the number of science, arts, and commerce graduates working in a company are 30, 70, and 50 respectively. If the figures are represented by a pie chart, then what is the angle corresponding to science graduates? So let's first talk about a pie chart. What is a pie chart? Pie chart is a pictorial graph, like pictorial representation of a certain, certain information. Like there is a circular shape, and we all know the angle for a circle is 360 degree. Okay, let me draw it again, the circular shape. And we all know the central angle is 360 degree. Let's say there are some informations, so we can represent it this way. Okay, there are various portion representing various information. Okay, now so how can we find the value in a pie chart? In a pie chart, the central angle of each slice of the pie is proportional to its value as compared to the total value. Okay, and the formula is theta, like this angle is called, say, theta. Theta equals to value of the slice. If it's given in percentage, so percentage, or in a number, then it's number, or in a fraction, it's then in a fraction value, value of slice by total value multiplied by total central angle, that is 360 degree. Okay, so here the number of science, arts and commerce graduates working in a company are 30, 70, 50. If these figures are represented by a pie chart, then what is the angle corresponding to science graduates? So we need to represent the data that is 30 into in terms of theta, in terms of angle. So here angle corresponding to the science graduates, angle corresponding to the science graduates let's say theta equals to number of science graduates by total number of graduates. Okay, so number of science graduates, total number of graduates multiplied by 360 degree. So here we already know the number of science graduates, that is 30, and total number of science, arts and commerce graduates, that is 30 plus 70 plus 50. 150 multiplied by 360 degree. 5, so I'll get 72 degree. So the value is 72 degree. Here option B is the correct answer. In question number 88, it is given for a histogram based on a frequency distribution with unequal class intervals, the frequency of a class should be proportional to, there are 4 options given. Okay, first of all, there are few points regarding histogram that I would like to make you remember. First of all, that is when constructing a histogram with unequal class widths, that means the class size are not equal in each case. Class widths, we must ensure that the areas of the rectangles are proportional to the class frequencies. So what I have written, when constructing a histogram with unequal class widths, we must ensure that the areas of the rectangles are proportional to the class frequencies. And remember, histogram and bar graph, both are different. Okay, in bar graph, the height of the bar denotes the value. But in histogram, it's not the height, but we need to consider the width in order to determine the height of each rectangle. So it is clear that the frequency of a class is proportional to the area of the rectangle, but not to its height. So here, the frequency of a class should be proportional to area of the rectangle. Option B is the correct one. In question number 89, it is given that the coefficient of correlation is independent of, there are four options been given. First, we will talk about coefficient of correlation. So, in a simple linear regression analysis, in a simple linear regression analysis, the coefficient of correlation is a statistics which indicates an association between the independent variable and the dependent variable. Now, also the coefficient of correlation represented by R. It is represented by R. It is represented by R, and its value lies between and positive 1. Okay, now when the coefficient of correlation is positive, when the coefficient of correlation is positive, such as, okay, we can assume that as a say 0.80, it means the dependent variable is increasing or or decreasing when the independent variable, I mean both are when the independent variable is increasing or decreasing. So when the dependent variable is increasing, also the independent variable is increasing. And when the dependent variable is decreasing, the independent variable is also decreasing. But now when it indicates when the correlation relation is negative. Okay. So when it's negative value, indicates an inverse association. Indicates an inverse association like the dependent variable is increasing, so the independent variable is decreasing. The dependent variable is increasing, decreasing when the independent variable is decreasing or increasing. Okay, so here also a coefficient of correlation of positive 0.8 or negative 0.8 indicates a strong correlation between the independent variable and the dependent variable. The independent variable and the dependent variable. Okay, and R, I mean the correlation coefficient of correlation of plus 0.20 or minus 0.20 indicates a weak correlation between the variables. Okay, when the coefficient of correlation is 0, when the coefficient of correlation is 0, I mean 0, then there is no correlation. Then there is no correlation. And R can be found as summation square root under whole square summation yi y bar whole square. Okay, so from the properties or the nature of the coefficient of correlation, from the properties of coefficient of correlation, we know that the correlation coefficient is independent. The coefficient is independent of the choice of origin and scale, of origin and scale. Okay, so here from this we can say that the coefficient of correlation is independent of both change of scale and change of origin. Option C is the correct answer. In question number 90, it is given that the following tables gives the frequency distribution of number of P's per P pod of 198 pods. Okay, so here number of P's and frequency is being given. First, let's talk about median. So median of in observations is the value. Median is the value at the central position when the data is arranged in ascending or descending order. So it's the value at the central position when the data is arranged in ascending or descending order. Now for if n is odd, then we can say median is the value uh, at n plus 1 by position, and if n is even, okay, then median is the average value of n by position and 1th position. Okay, so first write the table of cumulative frequency. So here number of P's, frequency and here cumulative frequency. So 1, 4, cumulative frequency is 4, right? Next 2, frequency 33, so cumulative frequency 37. Next for 3 frequency is 76, so the cumulative frequency is 76 plus 37, that is 113. Next 4 frequency 50, the cumulative frequency 163. Okay, for 5 frequency 26, so cumulative frequency 189. And 6 frequency 8, cumulative frequency 197. For 7 frequency 1, cumulative frequency 198. So since n equals to 198, which is even, correct? So the median will be the average values of median will be the average values of 198 by 2, that means 99th position, and 9 plus 1, 100th position. So let's check. From this table, we can see that 99th position and 100 positions both are giving the value that is 3. So therefore, the median of the above data is 3. Okay. Look here, the cumulative frequency is 37. So 99th and 100 both are more than 37 but less than 113. So these two are giving the value 3. So the median of the above data is 3. Here option A is the correct answer. In question number 91, it is given that if limit x tends to a to the power x minus x to the power a by x to the power, okay, it should be x to the power x limit. The question is x tends to a to the power x minus x to the power a by x to the power x minus a to the power a equals to -1, then what is the value of a? Okay, first of all, we will talk about indeterminate form. What is that? Indeterminate form. Any expression whose value cannot be defined, like 0 by 0, plus minus infinity by infinity, 0 to the power 0, infinity to the power 0, okay, or 0 to the power infinity, etc. These all forms are addressed as indeterminate form. Okay, now we will learn about L'Hospital rule. L'Hopital or L'Hospital's rule. So for differentiable functions, for differentiable functions like f of x and g of x, okay, the limit, say x tends to c, f of x by g of x are both are both are both 0, or both are plus minus infinite, like it will give us 0 by 0 form or infinity by infinity form, that means it is an indeterminate form, then it's equal to the limit x tends to c f dash x g dash x if it exits, the limit exits. So what I'm saying, that if we get any expression which is under indeterminate form, so how can we perform limit uh, on that function? We will differentiate the function first, and then we will find the limit of that derivative form. We will get the limit then if it exits, if the limit exits, right? So here the given expression, let me write it first. Limit x tends to a to the power x minus x to the power a, x to the power x minus a to the power a. Let's check. So here a to the power a minus a to the power a by a to the power a minus a to the power a. Yes, it's in indeterminate form since these are given 0 by 0. Now applying L'Hospital rule. First, we will differentiate this. Okay, so let's differentiate it. Applying ddx of a to the power x minus x to the power a by here limit x tends to a ddx of x to the power x minus a to the power a. First of all, let's remember some differentiation formula. So if we differentiate a to the power x, we will get a to the power x log a. Okay. Next, if we differentiate a polynomial x to the power n, we will get n x to the power n minus 1. Next, now we will differentiate here x to the power x, correct? So let's consider it y, x to the power x. Next, we will apply logarithm both sides, log x. Now differentiate ddx log y x log x. So here let me write this side, or ddx log y equals to x log x, or since log y, if we differentiate log y with respect to the x, we will get 1 by y dy dx equals to, it's in uv form, so x 1 by x plus log x. So d dy equals to y log x plus 1. Now we will put the value of y here, that is x to the power x. So it means if we differentiate x to the power x with respect to x, we will get x to the power x log x plus 1. Okay. Now let's write over here limit x tends to a. This will give us a to the power x log a minus a x to the power a minus 1 by x to the power x log x plus 1. Now if we differentiate a to the power a, we will get 0 because it's a constant. So I'm not writing anything. Now in the next line, okay, so in the next line, we will directly substitute the value for x, that is a. So here a to the power a log a minus a to the power a minus 1, also a to the power a log a plus 1. Now see, we will get a to the power a, we can take common from here and we will left with log a minus 1. Log a plus 1. Log a minus 1 log a plus 1. Correct. Now it was already given that this limit equals to minus 1. Correct. So here, therefore, log a minus 1 log a plus 1 equals to minus 1. Okay. Minus log a minus 1. So 2 log a, that is equals to 0. That means log a equals to 0. So it gives that a equals to 1. Now check the options. Here, option C is the correct answer. In question number 92, it is given a particle starts from the origin with a velocity in meter per second given by the equation dx by dt equals to x plus 1. The time taken by the particle to traverse a distance of 24 meter is, okay, so the differential equation is given in variable separable form. Okay, so the given differential equation dx by dt is in variable separable form. And why is it so? I will explain you while solving it. Variable separable form. Now look at the equation. There are two variables x and y. Now why is it being called variable separable form? Look here. I can easily separate these two variables to two different sides. Look, dx by x plus 1 and dt. Now integrating both sides, we get okay, so it becomes dt plus c, where c is the integration constant. So I can write log x plus 1 equals to t plus c. Remember, dx by x equals to log x. Since here x plus 1, so I wrote log x plus 1 equals to t plus c. Now look, the object starts from the origin, right? So if the object starts from the origin, then if the object starts from the origin, then t equals to 0 at x equals to 0. No distance traveled. So let's name it 1. It makes equation 1 c equals to 0. Therefore, the path of the particle is given by log x plus 1 equals to t, right? So the equation becomes log of x plus 1 equals to t. Now we will put all those values. So here the time taken by the particle to traverse a distance of 24 meter. Now for x equals to 24 meter, t is log 24 plus 1 log 25. Also we can write log 5 squared. So 2 log 5. Okay. Now let me check the time. 2 log 5. Here option C is the correct answer. In question number 93, it is given what is there is an integration given equal to, we need to find the value of these integrals. Okay, this is a definite integral. So first we will discuss about some rules or formulas regarding definite integrals. So here, let's say a to b f of x dx. So it will give us the value f of b minus f of a, correct? Next, let's say integration a to b fx dx. Okay, also it's equals to the integration a to b f of a plus b minus x dx. Remember, we are going to use these laws or rules somewhere in the solution. Okay, next, if, okay, this is 1, next is 2, next is 3. Let's say if f of x equals to, if f of x similar with a function equal with the function 2a minus x, then we can write 0 to 2a f of x dx equals to 2 of 0 to a f of x dx. Okay, next, acha, if a function fx, a function fx is even or odd, how can we find that? Is it even or odd? If the function is even, okay, even, then if f of x is even, then f of minus x equals to f of x. And then how will it behave in the integration? Like integration minus a to a f of x dx. So we can break it as minus a to 0 f of x dx plus, or f of, okay, since minus a to 0, it will be f of x minus of x dx 0 to a f of x dx. So it becomes, this also will becomes 0 to a f of x, this becomes 2 multiplied by 0 to a f of x dx. Okay, next, if the function is odd, what will happen if the function is odd? Then f of minus x will give you minus of f of x. And if you wish to find the integration from limit minus a to a f of x dx, it will be 0. The result, it will result in 0. Okay, now if f of x is periodic function, like if f of x, f of np plus minus x, it will be f of x. If f of x is periodic function for some number p and n, where both are in integers, correct? So here we are going to first use this concept, integration a to b f of x d is equal to a to b f of a plus b minus x. So the given integration, we can write I equals to 0 to a, let me check, yes, 0 to a f of a minus x by f of x plus f of a minus x dx. Okay, now next, 0 to a. Now look, a minus x can be written as this way also, f of a plus 0 minus a minus x, using that formula, which is this one, a to b f of x dx equals to a to b f of a plus b minus x dx. Okay, by f of a plus 0 minus x plus f of a plus 0 minus a minus x dx next equals to 0 to a f of x. So it's equals to 0 to a f of x by f of a minus x plus f of x dx. Okay, so here we also again got back I, so it becomes 2i equals to 0 to a f of a minus x. In a bracket I can write from 2, okay, so that you can also find the link. How is it possible to write this way? F of x plus f of a minus x dx plus 0 to a f of x a minus x plus f of x dx. So it now I can write, since both are same, so it becomes 0 to a, both will got cancelled, it becomes 1. So 1 multiplied by dx, that means a, 2i equals to a. So here I equals to a by 2. The value of this integration, since we assume it as I, so it's the value is a by 2. Option D is the correct answer. Look at it again. This formula we have used, a to b f of x dx equals to a to b f of a plus b minus x dx. First, I have assumed it as I. Then I put the formula, since it's 0 to a, that's why a plus 0 minus a minus x, a plus 0 minus x, a plus 0 minus a minus x. So from that second law I can write it f of x, okay, and okay, not here from 2. From 2 I should write here, because this is the simple calculation. Okay, so f of x by f of a minus x and f of x. So now it's become, look, 1 and I equals to a by 2. In question number 94, it is given that what is the limit of x tends to 2, x cube plus x square by x square plus 3x plus 2 equal to. First, let's discuss about continuity of a function. A function f of x is said to be continuous at a point x equals to a in its domain if limit x tends to f of x exists, or if its graph is a single unbroken curve at that point, or if we wish to represent mathematically, then f of x is continuous at x equals to n. That means limit x tends to a minus f of x equals to limit x tends to a plus f of x. That means right hand limit and left hand limit both exits and equals to limit x tends to a f of x. Okay, and we will get the value as f of x. So here in this given limit x tends to 2, x cube plus x square by x square plus 3x plus 2. Okay, how can we solve it? We can further, let's say, since this is a continuous, so we can directly put the value. So here 1 is the correct answer. Option B is the correct answer. In question number 95, it is given that if 0 to a f of x plus f of minus x dx, this integration is equals to integration minus a to a gx dx, then what is gx equal to? First, let's talk about definite integrals. Definite integrals. Okay, so here a to b f of x dx equals to a to b f of a plus b minus x dx, right? Next, if f of x equals to f of 2a minus x, then we can write 0 to 2a f of x dx equals to 2 multiplied by 0 to a f of x dx. Okay. Now we will talk about different type of function, like a function f of x is, let's say it's even. Okay. Then we can write f of x equals to f of minus x, and also minus a to a f of x dx will give us the value to 0 to a f of x dx. Okay, if this function is odd, right, then we can write f of uh, minus of f of x equals to f of minus x. Okay, and then minus a to a integration f of x dx will give us the value 0. Fine. Now look here, in this question, I mean for this question, we can assume that f of x is an even function. Okay, so here let f of x is an even function, right, for this given question. So we can write f of x equals to f of minus x, right? Now in RHS, sorry, in LHS, it's given 0 to a f of x plus f of minus x dx. So here 0 to a f of x plus f of x dx, because f of x is even function here, so we can write to 0 to a f of x dx. Also in RHS, it is given that minus a to a g of x dx. Now since here LHS equals to RHS, so we can write that minus a to a g of x dx equals to 2 0 to a f of x dx, correct? We can write this. So this will only possible when g of x and f of x both are even function. So this is possible only when g of x and f of x even function. Okay, now since our assumption was f of x is an even function, is an even function. So g of x must be an even function, must be an even function, right? That means we can directly say g of x equals to 2 of f of x, or x plus f of x. Also, 1 f of x can be written as f of minus x, because f of x is even function. So here we can say gx is equals to f of minus x plus f of x. Option B is the correct answer. In question number 96, it is given that what is the area bounded by y equals to root under 16 minus x square, comma y greater than equals to 0 and the x-axis. So first of all, let's talk about the concept first. So here, the area under the function, let's say the function is given as y equals to f of x from x equals to a to x equals to b, and the x-axis is given by the definite integral a to b f of x dx for curves which are entirely on the same side of the x-axis in this given range, x-axis in the given range. So if the curve is on x-axis and on the same side, then we will get the area by this definite integral. Okay. Now what happened if the curve on both sides of x-axis? If the curve are curves are on both sides of x-axis, then we calculate the areas of both the sides separately, and then we will add them together. Okay. Now these are the part of the area concept. Okay. So now let's talk about a few definite integral. If f of x dx integration will give us the value g of x plus c. Now then a to b f of x dx will give us g of x of a to b, that means gb minus ga. And one more very important integration formula, integration a square minus x square dx equals to x by 2 a square minus x square plus a square by 2 sine inverse x by a plus c. Okay, now let's talk about the given curve. So let's find the points where this curve meets the x-axis. Let's find the points where the curve meets the x-axis. That means on those points y will be 0. So we will make y 0 to get the value of x. So here y equals to 16 minus x square equals to 0, or x square 16, or x equals to plus minus 4. Correct? So the curve will looks like this. Minus 4, 0, minus 4 to 4, 0. Since the curve is entirely on one side of x-axis in the given range, that is x equals to minus 4 to x equals to 4, we have the required area minus 4 to 4. 16 can be written as 4 square minus x square dx. Now we will use this formula. So here x by 2, 4 square minus x square plus 4 square by 2 sine inverse x by 4 minus 4 to 4. Next, 4 by 2, 4 square minus x is, okay, in this place we will put 4, not x anymore. 4 square plus 4 square by 2 sine inverse 4 by 4 minus 4 by 2 4 square minus 4 whole square plus 4 square by 2 sine inverse minus 4 by 4. So it will give us the value 8 pi by 2 plus 8 pi by 2. That means 8 pi square units. Okay. So here the required area is option B, 8 pi square units. In question number 97, it states that the curve y equals to minus x cube plus 3x square plus 2x minus 27 has the maximum slope at which point? There are 4 options given. So first of all, the slope of a curve, let's say y equals to f of x at a point, is the value is the value of its first derivative. First derivative at that point. Okay, so that is, since y equals to f of x, so m equals to dy dx, or we can write ddx of f of x, correct? So here the slope is given of the curve, the slope of the given curve y equals to minus x cube plus 3x square plus 2x minus 27 will be given by m equals to y dash, that means dy d dash, or we can write ddx of minus x cube plus 3x square plus 2x minus 27. So I hope you all know the formulas. Like if we derivative of polynomial, we will get x multiplied by in x to the power n minus 1. If we multiply a constant, we will get 0. So look here, this one is the derivative. So let's write minus 3x square plus 6x plus 2 minus, or since there is nothing, I mean 0, no need to write it. Only minus 3x square plus 6x plus 2, right? Now here we have to find the point where the slope is maximum. So in order to maximize the slope, we must have m dash equals to 0, means dm dx, the first order derivative of equals to 0, and the second order derivative of m, that is m double dash, less than equals to 0. Now to get m dash equals to 0, now since m dash equals to 0, that means ddx of minus 3x square plus 6x plus 2 equals to 0. So from this equation, we will get a value of x minus 6x plus 6 equals to 0. Here, x equals to 1. Okay. And also, if we check m double dash, we will get minus, I mean ddx of minus 6x plus 6, that is minus 6 less than 0. So yes, it's verified, like at this point x equals to 1, the slope is maximum. Therefore, the slope is maximum at x equals to 1. Okay, so let's check the options. Here, option C is the correct one. In question number 98, it is given that a 24 centimeter long wire is bent to form a triangle with one of the angles as 60 degree. What is the altitude of the triangle having the greatest possible area? So first of all, the area of a triangle, with a fixed perimeter, is maximum when it is equilateral. Okay, this is the concept. Like the area of a triangle with a fixed perimeter will be maximum when the triangle is equilateral triangle. Okay, so here since so it's here they said the altitude of the triangle having the greatest possible area. So this triangle should be equilateral triangle. Since the perimeter is 24 centimeter, perimeter of equilateral triangle that is 3a. The formula is 3a. So therefore 3a equals to 24 centimeter. Here length of the side is 8 centimeter. Okay, and we also know the formula for finding height of the triangle. The formula is root 3 by 2a. This a formula applicable only for equilateral triangle. Okay, so here root 3 by 2 multiplied by 8 centimeter 4. So 4 root 3 centimeter is the possible is the altitude. So here option A is the correct one. In question number 99, it is given that if f of x equals to e to the power mod of x, then which one of the following is correct? First of all, differentiability of a function. What does it mean? That differentiability of a function, it states that a function f of x is differentiable at the point x equals to a function f of x is differentiable at the point x equals to a in its domain if its derivative is continuous at a. If its derivative is continuous at a. Okay, and continuous means, okay, first of all, we can say that limit x tends to, right hand limit f dash x equals to left hand limit a inverse dash x equals to limit x tends to a f dash x, or that will be f dash a. Okay, and now what about the modulus function? Modulus function, like mod of x defined as like x when x greater than equals to 0 and minus x when x less than 0. Okay, so here using the modulus function, using the modulus function, we have f of x, that is e to the power x when x greater than equals to 0, and f of x, that will be to the power minus x when x less than equals to 0. Okay, so using first principle of derivatives, we find that using first principle of derivatives, we find that limit x tends to 0 plus, right hand limit. So here right hand limit, that's why I'm taking this function e to the power x, because here x greater than equals to 0. So we will get 1, and for left hand limit, x tends to 0 minus of e to the power minus x, since it's f dash x. So f dash x will be, the first derivative of f of x will be minus of e to the power minus x, because when we derivative e to the power x, we will get e to the power x back. So here it will be -1. Since we can see that right hand limit and left hand limit, they are, sorry, it will be 0. They are not equal. X tends to 0 minus f dash x not equals to limit x tends to 0 plus f dash x. So the given function is not differentiable at x equals to 0. The given function is not differentiable at x equals to 0, or we can say f dash x doesn't exist. So here option D is the correct answer. F dash 0, since we are checking at the point 0, so f dash 0 doesn't exist. In question number 100, one of integration is given. So what is integral dx by sec x plus tan x equal to? So first of all, let's remember some of very important formulas of integration. That is integration tan x dx. Okay, so let me prove it. It will be easier for you to understand. Sin x by cos x dx plus c, right? Okay, so here we can write that, let's take a common minus and minus. Remember, when we differentiate cos x with respect to x, we get minus sin x, right? So here, if we derivative, if we differentiate, if we derivative cos x, we will get minus sin x. So we can write here minus ln cos x plus c. Okay, here c is the integration constant also, and ln cos x minus 1 plus c. So it becomes ln 1 by cos x, that is ln sin x plus c. So we got the formula integration tan x dx equals to ln sec x plus c. Look, I have already shown you the proof of this integration. Okay, ln is denoted for base e, remember. Now next sec x dx. Okay, integration sec x dx. We will get the value as ln, let me directly write it, sec x plus tan x plus c. Okay, and one more important formula from trigonometry, 1 plus tan square x equals to sec square x. So also we can write sec square x minus tan square x equals to 1, right? Now let's focus on the given integration. It's given here integration dx by sec x plus tan x, correct? Look, now there is only dx, so like there is 1 multiplied by dx, correct? So in place of 1, instead of 1, we can write sec square x minus tan square x by sec x plus tan x dx, right? So it's a square minus b square, so we can write a plus b by multiplied by a minus b by sec x plus tan x dx, correct? So these two will get cancelled, only we will left with sec x minus tan x dx. Now let's distribute the integration. We will get sec x dx minus integration tan x dx. So sec x dx means ln mod of sec x plus tan x, okay, and minus tan x means integration ln sec x, and plus c is the integration constant. So here the correct, this is the answer. Let's check with the options. Sec x plus tan x minus ln sec x. Here option D is the correct one. In question number 101, it is given, there is another integration given. Let's solve the integration. But before we start with the integration, let me write few formulas. First one is from trigonometry, that is sec square x minus tan square x equals to 1. Okay, one more, there is dx by x square plus a square will give us the value 1 by a tan inverse x by a plus c. Now if put a equals to 1, so it becomes dx by 1 plus x square, so it will become tan inverse x plus c. Okay, now one more thing, let's say tan inverse x equals to theta. So we can imply that tan theta equals to x. These are the rules from the concept. Now let's start with the given integration. So here it's given integration dx by sec square tan inverse x. Okay, sec square tan inverse x, right? Now let's name it 1, 2, and 3, so that we can properly write where we have used which formula. So from 1, I'm writing dx 1 plus tan square, 1 plus tan square. Here in the place of theta, it's given tan inverse x. So tan inverse x from the first rule, right? Now look, next dx by, okay, so 1 plus, I can take the square as the whole square, so tan of tan inverse x whole square. So now we can now compare it with this second formula, dx by 1 plus x square. Okay, so here x is tan, x is tan. Okay, first of all, no, before that we will check with the third formula. Tan, if I if I consider tan inverse x as theta, then tan theta will give me x. So in this case, dx by 1 plus tan inverse x as theta, it becomes tan theta. Again, tan theta would give me x square. So I can write x square from third law. Okay, and now look here, 2, I have already got this expression. So from 2, I can write the value of the integration will be tan inverse x plus c from 2, second formula. So remember tan inverse x. Okay, so here, yes, I have already got the final answer. Yes, this is the answer. We got it. Tan inverse x plus c. So option B is the correct one. In question number 102, it is given that if x plus y equals to 20 and p equals to xy, then what is the maximum value of p? Okay, to find the maximum value of p, here we will use the second order derivative test. Okay, so the method is second order derivative test. Fine. I will first discuss about all the steps of this method. Let if be a function defined on an interval I. Okay, so method, what are the methods? First step, calculate f dash x. Okay, next, second step, we will solve f dash x 0 and find roots of f dash x 0. Okay, let's say the root I got c, like so. That means, that implies that f dash c equals to 0 if c is the root, right? Suppose x equals to c is the root, right? Therefore f dash c equals to 0. Okay, next, third, calculate f double dash x, the second order derivative of f of x, and put x equals to c to get the value, to get the value of f double dash c. Now it will depend on the sign of the value, that means the sign of f double dash c, that whether at x equals to c, the point, it is a point of local maxima or the point is of local minima. If double dash c less than equals to 0, then it implies that x equals to c is a point of local maxima. Okay, if double dash c greater than equals to 0, it implies that x equals to c is a point of local minima. Okay, and if double dash c equals to 0, if it equals to 0, then we need to use the first order derivatives test. Okay, it implies we need to use the first order derivative test, right? Okay, so let's check. First, I have already discussed all the steps and of the method. Now I will imply this in this question. So here x plus y equals to 20 and p is x y, product of x y. So given x plus y equals to 20 and p equals to product of xy. That means p can be written as, let's say, x. If we substitute the value of y, so we will get 20 minus x. It becomes 20x minus x square. Okay, so p of x is 20x minus x square. P of x is the function. Let's find p dash x. It becomes 20 minus 2x. Okay, next, also let's find p double dash x, that means the second order derivative, that is minus 2. So look here, since I can skip this second point. Why? Because there is no scope of putting the value of x equals to c, because p double dash x I have already got it as a constant, right? It's a constant. There is no scope to put a point and get a value, uh, from it. So since already p double dash x less than equals to 0, so we can say that x equals to c is a point of local maxima. Now we have to find the value for x, so to get the point. Okay, so yes, let's make it 0, that px dash, so px dash equals to 0. I have already proved that at that point we will get local maxima, because p double dash x less than 0. So yes, now we are going to get that value. 20x minus 2x equals to 0. So we will get x equals to 10. X equals to 10. Okay. So we can say x equals to 10 is the point of maximum, right? So here option, what is the maximum value of p? That means y equals to 20 minus x, 20 minus 10, 10. This is the maximum value of y maximum. Y equals to 10 is the point of maximum also, if x equals to 10. So the maximum value, of p equals to xy, that is 10 multiplied by 10, 100. So here option 1 for A, first option is the correct one. In question number 103, what is the derivative of sine ln x plus cos ln x with respect to x at the point x equals to e? Very good. First of all, let's discuss ln. We find ln. Ln is defined to the base e. Ln is defined to the base e. Okay, whereas log is defined to the base 10, right? Next, what is the formula of derivative sine x? We will get cos x. Next, ddx of cos x, we will get minus sine x. Okay, and if we try to find the derivative of ln x or log x, we will get 1 by x. Now here the function is given sine ln x plus cos ln x. Okay, yes, let's start solving ddx of f of x. So yes, first we will derivative sine ln x. So first look here, listen to me very carefully. This sine ln x, first I will treat it as sine theta. Okay, means ln is the theta right now. So if we treat it as sine theta, we will get the derivative of sine theta as cos theta, or sine x as cos x. So yes, since here x or theta is ln x, so we will write cos ln x. Fine. Now look at the theta portion, that means ln x. We will now differentiate ln x. If we differentiate ln x, we will get 1 by x plus same. First, we will treat it as cos theta. So we will get the value that is minus of sine ln x. Minus of sine ln x. Okay. Next, multiplied by, look at ln x. If we differentiate that ln x, we will get 1 by x. So it becomes cos ln x by x minus sine ln x by x. Okay. So yes, next, it f dash x. Now we have to find the value of this derivative at x equals to e. Let's put the value f dash e. So it becomes cos ln e by e minus sine ln e by e at x equals to e. Okay. Now, since ln is defined to the base e, so we know that ln e give us the value 1, because ln e to the base e, obviously it will give us the value 1. Therefore, f dash e cos 1 minus sine 1 by e, or we can write cos 1 minus sine 1 by e. So here by e, 1 by E. So if dash E, this is the final answer, cos 1 minus sine 1 by E. This is the answer. Now let's check the options. Okay, we have to make a rectification. It will be cos 1 minus sine 1 by E. So here we can say that option A is the correct answer, because there must be X. Cos 1 minus sine 1 by E is the correct answer. In question number 104, it is given if x equals to e to the power t cos t and y equals to e to the power t sin t, then what is the value for dx dy at t equals to 0? There are 4 options given. First of all, let me discuss about few formulas of differentiation. ddx of e to the power x, we will get e to the power x. ddx of sin x, we will get cos x. Next, ddx of cos x, we will get minus sin x. Okay. Now, next, since look here, both the functions like x and y both are of function t, correct? So let's write x equals to e to the power t cos t. X is a function of t. So I can differentiate x with respect to t. So let's find dx dt. It will be, since it's in the u multiplied by v form. So the formula is d dx u v. Okay, so here u, first take u as the constant, keep u as the constant and differentiate v. Next, keep v as the constant and differentiate u. This is the formula. So here I will first keep it constant e to the power t and differentiate cos t. Next, cos t will be constant and differentiate to the power t by dt. So it will become e to the power t minus sin t plus cos t multiplied by e to the power t. So yes, e to the power t cos t minus e to the power t sin t. Okay. So dx by dt. Now, next, another one, y equals to e to the power, say e to the power t sin t, right? It's also in u multiplied by v form. So dy dt, also y is a function of t. So we will differentiate with respect to t. So e to the power t d dt sin t and plus sin t d dt. So here e to the power t cos t plus e to the power t sin t dy dt. Correct. Now, according to chain rule, okay, so according to chain rule, I can write dy dx as dy dt multiplied by dt by dx, right? So that means dy dt by dx dt. So here dy dx equals to dy dt first. So let's check the value of dy dt, e to the power t cos t plus e to the power t sin t. Now let's check dx dt, e to the power t cos t minus e to the power t sin t. So yes, e to the power t cos t minus e to the power t sin t. Okay, to the power t sin t. Acha. Okay, since they have asked us to find dx dy, never mind. I can again find the reciprocal of this. So dx dy, just write the reciprocal of this, cos t minus e to the power t sine t by e to the power t cos t plus e to the power t sine t. So we are asked to find the value at the point t equals to 0. So dx dt at t equals to 0 here. So I can write e to the power 0. Okay, e to the power 0 will give us the value 1, and cos 0 will give us the value also 1. But sine 0 will give us the value 0. That means 1 minus 0, 1 plus 0. Okay, so yes, we got the value 1. So the correct option is option B is the correct one. In question number 105, it is given that what is the maximum value of sine 2x multiplied by cos 2x? Again, this question we will solve in the method of second order derivative test. So I have already discussed this method in one of the previous question, but still, let me tell you, again make you remember what is second order derivative test. Let f be a function, okay, defined on an interval. So the first step is calculate f dash x, correct? Next we will find the root of f dash x. So we will make it f dash x 0 and solve it. We will get a value for that. Okay, let's see, x equals to c is the root of f dash x. Okay, now next we will calculate f double dash x. Fine. So, okay. So after that, we will put x equals to c in that f double dash x. It will make, we will make it f double dash c. Now, the sign of f double dash c will make it that whether we will decide that whether x equal to c is a point of local maxima or minima. In question number 105, it is given that what is the maximum value of sine 2x multiplied by cos 2x? Okay, so before we start with the solution, first we will discuss about second order derivative test. So let's say second order derivative test. Okay, so let's say let f be a function defined on an interval, right? So the first step is calculate f dash x, calculate f dash x, right? Next, we will solve this f dash x to find the roots of f dash x. Solve f dash x 0 equal f dash x equals to 0. Suppose x equals to c is the root of f dash x, right? Suppose x equals to c is the root of f dash x equals to 0, right? So in the next step, we will calculate f double dash x, the second order derivative of f of x. Calculate f double dash x, right? So here, after this, we will put x equals to 0, x equals to c, put x equals to c in f double dash x in this say in this function, right? And then we will check the nature of f double dash c. If double dash c less than equals to 0, then we can say x equal to c is a point of local maxima. X equal to c, point of local maxima. Okay, now if double dash c greater than 0, then x equal to c, point of local minima. Okay, and if x equals to c equals to 0, if of c equals to 0, then we can say we need to use the first order derivatives test. Okay, uh, we need to use first order derivative test right? So okay, now let's start with the given function, that is the product of sine 2x and cos 2x. So here let f of x equals to sine 2x cos 2x, then f dash x, so it's in the u by u multiplied by v form, correct? So it will be, first we can keep sine 2x as constant, so it will give us 2 cos okay 2 minus sine 2x, and already there is 1 sine 2x, so it's become minus 2 sine squared 2x. Now after keeping cos 2x as the constant, so yes 2, okay 2 another cos 2x, so it becomes 2 cos square 2x. So we can write it as 2 cos square 2x minus 2 sine square 2x. Next f dash x, 2 cos square 2x minus sine square 2x, 2 cos 2x. Okay, because this is the formula of cos 2x, that's why I have replaced it with cos 2x. Okay, so it should be cos 4x, because the formula is cos 2 theta cos squared theta minus sine squared theta. Here in the place of theta we are having 2x, so cos 2 theta will be 2 cos 4x. Okay, remember that, make it correct, 2 cos 4x. So here f dash x equals to 2 cos 4x. Now we are going to find the root of this function. So if dash x equals to 0, that implies dash 2 cos 4x equals to 0. So we know that where we got the value of 0 for cos, that is for pi by 2, correct? So cos 4x equals to cos pi by 2, that means x equals to pi by 8. Okay, now pi by 8. Now let's find the second order derivative. So it becomes minus 8 sine 4x, correct? Minus 8 sine 4x. Now if we put if double dash pi by 8, we will get minus 8 sine uh, pi by 2, that means minus 8, which is less than 0. So since if double dash c less than 0, that is point of local maxima, right? So x equals to pi by 8 is the point of maxima, correct? Is the point of maxima. So the maximum value, of f of x equals to, that is okay, here f of x is given here sine 2x multiplied by cos 2x is given by f of pi by 8 sine pi by 4 cos pi by 4. So 1 by root 2, both will give us the value 1 by root 2, that means half. So here let's check with the options. Option A is the correct answer, half. In question number 106, it is given that consider the following statements in respect of the points P, comma P minus 3, Q plus 3, comma Q, and 6, comma 3. So the first statement is the points lie on a straight line And the second statement is the points always lie in the first quadrant only for any value of P and Q. Which of the above statements is or are correct? Let's talk about with the first line, first statement. The points lie on a straight line. Okay, so since we can see that here we are given with two dimensions, I mean only two values like of x coordinate and y coordinate, so we can say that these 3 points in a 2D plane, right? So given p comma p minus 3, q plus 3 comma q, and 6 comma 3 are 3 points in 2D plane. Okay, now since statement 1 is saying the points lie on a straight line, so we need to prove that we need to check whether the points are lying on a straight line or not. So as we know if 3 points, let's say A x1 y1, B x2 y2, and C x3 y3 are on the same line, I mean are said to be collinear, or said to be collinear if the area of the triangle ABC is 0. That is, if we represent by the determinant, we will get y1 1, x2 y2 1, and x3 y3 1 equals to 0. Correct? Now let's put all the values here. Let a equals to p comma p minus 3, b equals to q plus 3 comma q, and c equals to 6 comma 3. Okay, so let's put all the values. P minus 3 1, q plus 3 q 1, 6 3 1, 6 3 1. Yes, so yeah, if we expand it in the to respect to the first row, we will get it p q minus 3 minus p minus 3, next q plus 3 minus 6 and plus 1, it becomes 3q plus 9 minus 6q. Okay, so here pq minus 3p minus we have to multiply it, minus pq minus 3p minus plus 6p minus plus 3q plus 9 minus plus minus 18. Okay, also here 3q plus 9 minus 6q. Let's check it again. Pq minus 3p minus pq plus minus 3p plus 6p, next minus plus 3q plus 9 minus 18, 3q plus 9 minus 6q. So look here, pq minus pq got cancelled, next 3p with 6p, q 18, and here we are okay, here we are plus 3q will got cancelled with minus 6q. Yes, so it will give us the value 0, right? So as we can see that area of triangle ABC equals to 0 for any value for any value of P and Q. So here statement 1 is correct. That means these 3 points are collinear. The points lie on a straight line. Okay. Therefore, statement 1 is correct. Right. Now we will talk about statement 2. The points always lie in the first quadrant only for any value of P and Q. Look, as we can see that, so here as we can see that for any value of P and Q, it is not necessary that the points lies in the first quadrant. Okay, right. I can give you one example here. If I say that, for any value of P and Q, right? So we can assume the value of P as -1. So then it will become -1 and -4. It's not like in the first quadrant, right? So that's not the correct statement. So hence statement 2 is false. So only one statement is correct. So one only option. In question number 107, it is given that what is the acute angle between the lines x minus 2 and root under 3x minus y minus 2 equals to 0. So we know that let theta be the angle between two lines of having slope say m1 and m2. Okay, then the acute angle between the lines is given by formula is tan theta, that is mod of m2 minus m1 by 1 plus m1 multiplied by m2. Okay, so here the slope of the line x minus 2 is the slope of the line x minus 2 is, look here, x minus 2 means it will looks like this. Say this is the line, correct? So here theta is 90 degree. So tan 90 degree gives us the value undefined, that is infinity. So is infinity. Okay, and the slope of the line, that is root 3. Okay, so here it's given root 3 x minus y minus 2 equals to 0. So here I mean, if I write it again, it's only root 3. Okay, not root 3x. So root 3 x minus y minus 2, that is root 3. So root 3 means we can say here m1 infinity and m2 root 3, right? And the angle between the given lines is theta. Okay, so here tan theta equals to m2 minus m1, that is root 3 minus infinity, or we can say that, okay, not this way, we can write it another way. So look here, we can say m2 minus m1 by 1 plus m1 multiplied by m2, right? That is the formula. Now if we take m1 common, so if we divide by m1 both the numerator and the denominator, it will become m2 by m1 minus 1, 1 plus m2. Okay, 1 by m1 plus m2, correct? That means here, so 1 by infinity means 0, correct? And also m2 root 3 by infinity, it is not defined, so we will get the value as tan theta equals to 1 by infinity means 0, so 0 plus m2 means root 3, and here 1 mod of minus 1 by root 3, so it will become 1 by root 3. So it gives that theta equals to 30 degree, because we know at the angle 30 degree tan give us the value 1 by root 3. So here option 2, yes, option 2 is the correct answer, tan 30 degree. Make one, okay, make one correction, that here this is root 3, not here, not, okay, root 3x minus y minus 2, root 3x minus y minus 2 equals to 0. Okay, the point of intersection of diagonals of a square ABCD is at the origin, and one of its vertices is at a 4, 2. What is the equation of the diagonal BD? First of all, we know there are various types of representation of equation of a straight line, and one of them is the equation of a line passing through the point x1 y1 and having the slope m is given as the equation is y minus y1 equals to m multiplied by x minus x1. Okay, now focus on the given question. The point of intersection of diagonals of a square ABCD is at the origin, and one of its vertices, that is A, the coordinate is 4, 2. Okay, so the diagonal AC passes through the origin. Okay, AC passes through the origin. Now we know that the slope of the line joining the points x1 y1 and x2 y2 is, that is m equals to y2 minus y1 x2 minus x1, right? So here one point is A, that is 4, 2, and another point is origin, that is 0, 0. So therefore the slope of line AC, since AC passes through the origin, right? AC passes through the slope of the line, AC passes through the origin, is given by 2 minus 0, 4 minus 0, that is half. Okay. Now in the square ABCD, in the square ABCD, the diagonals AC and BD are perpendicular to each other. Perpendicular to each other. Okay. That means slope of AC, product of slope of AC and slope of BD equals to -1. Slope of AC multiplied by slope of BD, that is -1. Okay. So the slope of BD is so the slope of BD is -2 because it's half, right? Like half equals to, say, m equals to -1. That means m will be -2. That's how we got -2. Correct. Now, as we know, the equation of a line passing through the point x1, y1 and having the slope m is given by y minus y1 equals to m multiplied by x minus x1. So we are going to use that formation. The equation of BD whose slope is -2 and passes through origin through 0, 0 means origin is given by y minus 0 equals to -2 x minus 0. So here 2x plus y equals to 0. Now let's check with the options. Option 1, A is the correct one. 2x plus y equals to 0. In question number 109, it is given that if any point on a hyperbola is 3 tan theta, 2 sec theta, then what is the eccentricity of the hyperbola? First of all, let me give you the concept of general equation of an hyperbola, that is x square by a square minus y square by b square equals to 1. And the formula for finding eccentricity is E equals to root under 1 plus b square by a square. Okay. Now here, since any point on the hyperbola t 3 tan theta, 2 sec theta, we can put this to value. X equals to 3 tan theta, y equals to 2 sec theta. Let's put it 9 tan square theta by e square minus 2 means 4 6 square theta by b square equals to 1, right? Now, if we assume that a square equals to 9 and b square equals to 4, so it will give us the expression tan square theta minus 6 square theta equals to 1, right? But whereas we know that 6 square theta equals to 1 plus tan square theta. That means 6 square theta minus tan square theta equals to 1. But this is giving completely opposite, whereas tan square theta minus 6 square theta equals to 1. That means this is not the hyperbola. Here they are referring that we have assumed, but the hyperbola that has been addressed here, that is the conjugate of that hyperbola. So the general form of conjugate hyperbola of 1, if I name it 1, 1, so that is y square by a square minus x square by b square equals to 1. Okay, so look here. Like if I try to write it this same way, we will get it as -1. So that's how we got that this is the mm, this is the conjugate hyperbola. That's what they're addressing. Now if we put the values, say 3 tan theta, so let's say 3 tan theta comma 2 sec theta, 2 sec theta, a point on this hyperbola, so we will get 9 tan square theta by, or we can say, yes, we can say that in question number 109, we have seen that if any point on a hyperbola is 3 tan theta comma 2 sec theta, then what is the eccentricity of the hyperbola? So first, let's talk about hyperbola. What is the general equation of an hyperbola? That is x square by a square minus y square by b square equals to 1. And the formula for finding eccentricity is E equals to 1 root under 1 by b square by a square, right? So here it is given that this point 3 tan theta comma 2 sec theta, it's been lying on the on this hyperbola. Okay, that means this point will satisfy the equation of the hyperbola. Let's put this point, the point 3 tan theta comma 2 sec theta lies on the hyperbola, on the hyperbola. So we can write, so here we can write 9 tan square theta by a square minus 4 sec square theta by b square. Let's name it equation number 1. So from 1 equals to 1. Okay, right? Now look here, we can assume that a square equals to 9 and b square equals to 4. We can assume, okay? Remember, we are assuming this. So we will get tan square theta minus sec square theta equals to 1. But from the standard identities of trigonometry, we know that sec square theta equals to 1 plus tan square theta, correct? That means sec square theta minus tan square theta equals to 1. So these two values contradicts each other. Correct. So from here, I mean, it should, if I write in terms of tan square theta, it should looks like tan square theta minus sec square theta equals to, say, -1. So these are not matching. That means this here, that particular hyperbola they are talking about is not this type of hyperbola. So the another form of another general equation of the of an hyperbola is y square by a square minus x square by b square equals to 1. This is the general form they are referring it here. Fine. Okay, so now let me put the point. The point is 3 tan theta comma 2 sec theta. Remember, so now let's put it. If I put the, since this point lies on the hyperbola, I can, this point will satisfy the equation. So let's put it. So here I will write 4 sec square theta by a square minus 9 tan square theta by b square equals to 1. So now if a square equals to say 4 and b square equals to 9. So it will give us the value sec squared theta minus tan squared theta equals to 1. So now look here, it matches with this value with the which we got from the standard identity of trigonometry. That means it satisfied the general equation. So yes, they are talking about this form. So here we have got the value for a square and b square. So now remember here e square equals to 4 and b square equals to 9. Therefore, e equals to root under 9 by 4 because root under 1 plus b square by a square. So 9 plus 4, it becomes 4 plus 9 by 4 root under 13 by 4. So it becomes root 13 by 2. Okay, let's check the options. Is option D is the correct answer. In question number 110, it is given that consider the following with regard to a eccentricity of a conic section. There are 4 statements being given: E equals to 0 for circle, equals to 1 for parabola, and E less than 1 for ellipse. So let's check whether any one of the options or any 2 of the options or all the 3 options are correct or not. So here, what is eccentricity? First, let's talk about that. Eccentricity, so the constant ratio of distance of point lying on conic from focus to its perpendicular distance from directrix is called the eccentricity of a conic section and is denoted by E. So the constant ratio of distance of point lying on conic from focus to its perpendicular distance from directrix is called the eccentricity of a conic section, is denoted by E. I can show you with the help of a parabola. Okay, look here. So this is a general diagram of a parabola. Let's say here is the focus. Okay, that means the perpendicular distance from the focus. Okay, and there is a random point, say P. Fine. So here, so this PN is the perpendicular. PN is perpendicular on the axis, right? And here PM is a perpendicular on the directrix. This is the directrix. Fine. This is axis and this is directrix. So here we can say that the constant ratio of distance of the point lying on the conic from focus to its perpendicular, that means PN is to PM, that is called to its perpendicular distance from directrix, that is called the eccentricity, that is being referred as E. So I am explaining you in the point of view from the parabola. Fine. So it's same for parabola, I mean for every conic section: parabola, ellipse, hyperbola, circle. So now let's talk about how the value got changes for eccentricity when for every other conic sections. So for ellipse, for an ellipse, the value of E is less than 1. Okay. Next, for a parabola, like for a parabola, here I have drawn a parabola. Okay, for a parabola, E equals to 1. That means this ratio is always equals to 1. If this ratio is 1, then we can say that it will make a parabola. The conic section will appear as a parabola. For a hyperbola, eccentricity is greater than 1. And for a circle, eccentricity is equals to 0. Also, remember, for a straight line, eccentricity equals to infinity, right? Now let's check. The first statement was E equals to 0 for circle. Yes, statement 1 is correct. Next, E equals to 1 for parabola. Also, second statement is correct. Next, E less than 1 for ellipse. Yes, the third sentence is also correct. So we can say which of the above statements is or are correct. 1, 2, 3. All the statements are correct. Here option D is the correct answer. In question number 111, it is being given that what is the angle between the lines having direction ratios 636 and 330? So look here, the angle, okay, so the angle theta between two lines, whose direction ratios are proportional to A1, B1, C1 and A2, B2, C2 respectively. So respectively, that is given by the angle theta. The value of angle theta is given by as cos theta mod of A1, A2 plus B1, B2 plus C1, C2 by root under A1 square plus B1 square plus C1 square multiplied by A2 square plus B2 square plus C2 square. Okay. So here we have to find the angle between two lines having direction ratios 636 and 330. So we can write here we can write that E1, that is 6, B1, 3, C1 also 6 and A2, 3, B2, 3 and C2, 0. Correct? Yes. Now let's put all the values in this formula of cos theta. We'll get the answer. Therefore, cos theta equals to mod of 6 multiplied by 3, 3 multiplied by 3 plus 6 multiplied by 0, 6 squared, 3 squared, 6 squared, 3 squared, 3 squared, 0. So here we will get the value 6 3 is 18 plus 9. So 27. Also here we will get the value that is 36 plus 9 plus 36. Correct? So it will give us the value 81. And here also 9 plus 9, 18. Okay, so that means we are getting the answer 9 and 3, and here also 3. So 1 by root So cos theta equals to 1 by root 2, correct? So that means we know cos gives us the value 1 by root 2 at the at an acute angle, that is 45 degree. So cos theta equals to cos pi by 4, theta equals to pi by 4. So here option B is the correct answer. In question number 112, it is given that if, okay, since it's written 1, it will be L. Please do the rectification. L, M, N are the direction cosines of the line x minus 1 equals to 2y plus 3 equals to 1 minus z. Then what is? It will be L to the power 4. It will be L to the power 4 plus m to the power 4 plus n to the power 4 equal to. Okay, so let's start the solving solution. First of all, let me explain you that if A, B, C are the direction ratios of a line passing through the point say x1, y1 and z1, then we can represent the equation of that line is the equation of line is given by so x minus x1 by A equals to y minus y1 by B equals to z minus z1 by C. Okay, and also if there is a relation between direction ratio and direction cosine. So if A, B, C are the direction ratios of a line, then the direction cosine of the line is given by okay, so remember LMN, with LMM we represent direction cosine of a line. So L is A by root under E square plus B square plus C square. Okay, M equals to B by root under A square plus B square plus C square, and N equal to C by root under L square plus M square plus N square. Okay, now let's look at the given question. So here line is being given x minus 1 equals to 2 multiplied by y plus 3 equals to 1 minus z, correct? So here, okay, so already I have said that given L, M, N are the direction cosines of the line, that is x minus 1 equals to 2, y plus 3 equals to 1 minus z, right? So this equation can be rewritten as x minus 1 by 1, okay, or y plus 3 by half, or z minus 1 by minus 1. We also can write in this way. Now by comparing, let's name it 1 and 2 and this equation as 3, by comparing 1 and 3, by comparing 1 and 3, we can write that, look here, so we can write A equals to 1, B equals to half, and C equals to -1, correct? Comparing 1 and 3, we get A equals to 1, B equals to half, and C equals to -1, correct? Now, so putting all this value, we can easily get the values of direction cosines. So therefore, L is, or the direction cosine of the given line, is, so L equals to, that is 1 by root under 1 square plus half square plus -1 whole square. That will give us value 2/3, right? Next, M equals to 2, okay, no, M equals to 1/3. So yes, sorry, not 1/3, half by same 1 whole square plus half whole square plus -1 whole square. Okay, so it will give us the value 1/3. Okay, next, Z -1 by 1 square plus half whole square plus -1 whole square. So it will give us the value -2/3. Now the required expression which we need, which we are asked to find the value, L to the power 4, M to the power 4 plus N to the power 4. So L to the power 4, M to the power 4 plus N to the power 4. Now 2/3 whole to the power 4, 1/3 whole to the power 4 plus -2/3 whole to the power 4. So we got, okay, so we got 16 by 81 plus 1 by 81 plus 16 by 81 again. So 33 by 81, further we can simplify it, we will get 11 by 27. This is the answer. Let's check with the options. Yes, option B is the correct answer here. In question number 113, it is given that what is the projection of the line segment joining A, the coordinate is 1, 7, -5, and B, -3, 4, -2 on x-axis. So the projection of any point on A, B, C, I mean the point we are assuming here of any point, that is ABC, on x-axis is A 0, 0. Okay, for on y-axis is 0, B, 0, and z-axis is 0, 0, C. Okay, so here the projection of point A on y-axis is the projection of A, the coordinate is 1, 7, -5 on y-axis is 0, 7, 0. And the projection of point B, -3, 4, -2 on y-axis is 0, 4, 0. So we can assume it as C, that's 0, 7, 0, that point, and D 0, 4, 0. Okay, and also we know O is the origin, coordinate is 0, 0, 0, origin, right? Therefore, OC is of 7 units and OD is of 4 units, right? So let the projection, of line segment, AB on y-axis is M. So, and we will get the value of M by OD minus OC. So here 7 minus 4 equals to 3 units. So the correct option is option C, 3 units. In question number 114, it is given that what is the number of possible values of k for which the line joining the points k, 1, 3 and 1, -2, k plus 1 also passes through the point 15, 2, -4. First, before we start solving, we will discuss few concepts. So first is the direction ratios, the direction ratios of the line joining the points, x1, y1, z1 and x2, y2, z2 is given by A equals to x2 minus x1, next B equals to y2 minus y1 and C equals to z2 minus z1. Okay. Also, one more thing, if this is first concept, the second one is if A, B, C are the direction ratios of a line passing through the point x1, y1, z1, then the equation of the line can be written as the equation of the line is given by x minus x1 by A equals to also y minus y1 by B equals to z minus z1 by C. We are going to use this concept throughout our solution. Fine. Now look here. Let's focus on the question. The line joining the points, K1, 3 and 1, -2, K plus 1 also passes through the point 15, 2 comma minus 4 for how many possible values of k? That's what the question. Okay, so we can find the direction ratios of the line joining these 2 points with help of this formula. Correct. So here, so the direction ratios of the line is equals to 1 minus k, b equals to minus 2 minus 1, that is minus 3, and c equals to k plus 1 minus 3, that is k minus 2, right? Also, it is given that if ABC is the direction ratio, then the equation of the line can be written as x minus x1 by A, y minus y1 by B, and z minus z1 by C, right? So the equation, the equation of the line with direction ratios A, B, C, and passing through the point and passing through the point. Another point is, say, okay, K13. K13 is given by x minus x1 by A, 1 minus k, y minus y1 by B, correct, equals to z minus z1 by C. Look here, this is the equation of the line, and it is given that the line represented by this equation also passes through the point 15 comma 2 comma minus 4. Let's say equation number 1. So 1 also passes through 15 comma 2 comma minus 4. So we can substitute the value x, y, z with 15, 2 and minus 4, correct? Therefore 15 minus k by 1 minus k equals to 2 minus 1 by minus 3 minus 4 minus 3 by k minus 1. With first two ratios, we will first proceed with the first two ratios. 2 minus 1 minus 3. So yes, 1 by minus 1 by 3. So we got 45 minus 3k minus 1 plus k. Okay, so here 4k equals to 46. That means k equals to 23 by 2. Also now taking second and the third ratio, minus 7 by k minus 2, k minus 2, 21, we got k equals to 23. So here from this two, from this two value, we can say the possible value of k Therefore, for two values of k, this is possible. Values of k, this is possible. Okay, so option C, 2 is the correct answer. Okay. In question number 115, it is given that the foot of the perpendicular drawn from the origin to the plane x plus y plus z equals to 3. So first of all, perpendicular distance of a plane ax plus by plus cz plus d equals to 0 from a point px1, y1, z1 is given by the formula is d mod of ax1 by1 cz1 plus d by root under a square plus b square plus c square. Okay, so here the question is given that from the origin to the plane x plus y plus z equals to 3, we have to find the foot of the perpendicular. So let a x y z be the foot of the perpendicular drawn from the origin to the plane y plus z equals to 3. So the distance between the origin and the plane is given by, so the distance so the distance between the origin and the plane, that is x plus y plus z minus 3 equals to 0, is given by d equals to minus 3 1 square 1 square 1 square mod of 3 by root 3, that is 1 by root 3. This means the length of the line joining the origin and the point A is 3, is 3, yes. Okay, so okay, it will be not 1 by root 3, sorry, it will be root 3 only. So the length of the line joining the points origin and A is root 3, correct? So from the given options, as we can see, from the given options, only only option C, like from only this point is having the distance of root 3 unit from the origin. Okay, so the distance between the point 1 1 1 the point between this and origin is root 3 units. So we can say 1, 1, 1. This is the foot of the perpendicular. Option C is the correct answer. In question number 116, it states that a vector R equals to, there is a vector sign, okay, I cap plus B J cap. It will be I cap, okay. So here it is inclined to both X and Y axes. If the magnitude of the vector is 2 units, then what are the values of A and B respectively? So first of all, the scalar product of two vectors A and B is given by mod of A mod of B cos theta. Okay, so here the given vector is R A I cap plus B J cap is equally inclined to X axis and Y axis. Okay, and and the magnitude of the vector is 2 units. So magnitude can be written as mod of R. 2 mod of R means root under A square plus B square equals to 2. So we can write A square plus B square equals to 4. Let's name it equation number 1. Now, since the vector R A I cap plus B J cap is equally inclined to both X and Y axis. Okay, so we can assume that let theta be the angle between the vector and both the axes. So cos theta equals to A by 2, because root under A square plus B square equals to 2, and also that is B by 2. Therefore, we can write A equals to B. So now we can substitute this value in equation number 1. Substituting equals to B in 1, we get, say, 2B square equals to 4. So B equals to root 2. Therefore, A equals to also root 2. So that means the value for values of A and B respectively, root 2 comma root 2. Option C is the correct answer. In question number 117, it is given that consider the following statements in respect of a vector C vector equals to A vector plus B vector, sum of these two vectors A and B, where mod of A vector equals to mod of B vector and not equals to 0. There will be a vector sign. So the first statement is C vector is perpendicular to the vector of A vector minus B vector, and C vector is perpendicular to the vector of, I mean cross product of A vector and B vector. So let's start solving. First of all, we know that the scalar triple product of three vectors is 0. Okay, if any two of them are equal. Okay, and the second concept is if vector A is perpendicular to the vectors B, then we can write the scalar product of them is 0. Okay, so in this question it is given that C vector equals to the sum of this two vector A and B, where mod of A mod of B equals to 0 and not equals to 0. That answer. Now look at the statement 1. Statement 1 states that C is perpendicular to A vector minus B vector, right? So we can write then C vector. We can check that whether the scalar product of these two is minus or not. Okay, so let's check. Now in place of C we will replace it with A vector plus B vector, A vector minus B vector, right? So now we can write mod of E square minus A vector B vector plus A vector minus whole square. Okay, so here as we know that the scalar product of A and B equals to the scalar product of B and A. Therefore, we can write not mod bracket equals to A square, these two will got cancelled, minus mod of B vector. Okay, since it is given that mod of A vector equals to mod of B vector, that means this will give us the value 0. Therefore, C vector equals to 0. Hence, statement 1 is true. Statement 1 is true. That is, C is perpendicular to this vector. Now, let's check statement 2. C is perpendicular to the vector product. Okay, so yes, so now we are going to find C. Okay, vector product. So yes, C product. Now let's distribute it. So as we know that the scalar triple product of three vectors is 0 if any two of them is 0. So we can say therefore A vector B vector equals to 0. Reference is this. First concept, the scalar triple product of three vectors is zero if any two of them are e- are equal. Okay, so hence, therefore, you can say statement 2 is also correct. Statement 2 is true, right? Statement 1 is 2 and 2 is 2. That means both the statements are correct. So here option C is the correct answer. In question number 118, it is given that if A vector and B vector are two vectors such that mod of A plus B equals to mod of A minus B equals to 4, then which one of the following is correct? First of all, the scalar product of two vectors that is A and B is given by mod of A mod of B cos theta. Okay, and also if the vectors A and B are perpendicular, then the scalar product of A and B will be 0. Okay, so here given equals to 4, we can square both of the sides. Okay, next, so it means okay, now we can write class equals to equals to 0, or okay, before that we know from here we can say this two scalar product is equals to scalar product of B and A. Therefore, we can write class 2 so both side got cancelled. Now we can write 4 equals to 0. That means scalar product of A and B equals to 0. So from it we can imply that A product of scalar vector A must be perpendicular to vector B. Here option C, A must be perpendicular to vector B. Option C is the correct answer. In question number 119, it is given that if vector A, vector B, and vector C are coplanar, then what is the value of the given expression? First of all, let me give you some concepts regarding three vectors are coplanar. So three non-zero vectors non-zero vectors A, B, and C are coplanar if and only if A, B, C equals to 0. Okay. Also, some properties of scalar triple product I will introduce to you. So, properties is of scalar triple product. First one is ABC equals to BCA equals to CAB. Next, ABC equals to, if B changed its position, so it become BAC. Now minus of CBA, or it becomes A minus of ACB. Another one is, let's say, A plus B CD. That means ACD plus BCD. Lambda A comma BC. So we can take common lambda A, B, C. Okay. Now let's look at the given expression. So since here A, B, and C are coplanar, that is, we can write ABC equals to 0. Okay. ABC equals to 0. Now next, so 2A, 3B, 4C vector, we can write it as 2A, 3B, 4C vector, and 5B, 3C, 6A vector, 5B, 6A vector. So, okay, now let's write the given expression. So C plus right? As we know that BC equals to BC equals to CAB, so we can write it this way. Equals to 2A, 3B, 4C plus 6A, 5B, 3C vector. Okay, bracket, and since ABC equals to BCA equals to CAB. Okay, that's fine. Now, next. So, okay, here also we can write from it that 24 ABC plus 90 ABC. C. Why? Because since lambda A BC equals to lambda of A B C. The same things we have used here, right? Now, as we know that A, B, C, three non-zero vectors are coplanar, that means A, B, C will give us 0. So here 24 0 plus, or we can simply write the whole expression will give us, okay, since A, B, C equals to 0, because these three vectors are coplanar. So equals to 0. That is equals to 0. So here option C is the correct answer. In question number 120, it is given that consider the following statements. First, the cross product of two unit vectors is always a unit vector. 2. The dot product of two unit vectors is always unity. 3. The magnitude of sum of two unit vectors is always greater than the magnitude of their difference. Which of the above statements are not correct? So first, let's discuss few concepts. First of all, the cross product of two vectors A and B is given by mod of A mod of B sine theta in cap, and in cap is the unit vector, okay? Sine theta. Next, the scalar product of two vectors A and B is given by cos theta, and also if E vector is a unit vector, then A vector is 1. Now let's start discussing with the first statement. Okay. Statement 1. The cross, it is given that the cross product of two unit vectors is always a unit vector. Let's check. Let A and B are two unit vectors. Since they are unit vectors, so we can write equals to 1 from 3, right? Now, the cross product of these two vectors A and B vector is given by, now, sin theta n cap and sin theta. So that means here since both are unit vectors, so we can write only sin theta. But we know the value of sin theta, the range of the sin theta is -1 to 1. Value lies between -1 to 1. The range of sin theta is -1 to 1. So it is not necessarily true. So it is not necessarily true that the cross product of two unit vectors is always a unit vector. Okay, that means statement 1 is false. Statement 1 is false, right? Next, statement 2. So here the dot product of two vectors is always unity. That is what statement 2 states. So we have assumed that A and B two unit vectors. So we can write 1 and mod of B vector 1, right? Now the dot product means cos theta, correct? So this implies that will give us the value only cos theta, correct? So here also the range of cos theta, the range of cos theta is same -1 to 1. So it is not necessarily true. So again, it is not necessarily true that the dot product of two unit vectors is always a unit vector. Okay, so again statement 2 is false. 2 is false, right? Now check statement 3. Statement 3 states that the magnitude of sum of two unit vectors is always greater than the magnitude of their difference. So let vector A is I cap and vector B is J cap. So as the two vectors, I mean A and B are two unit vectors, so we can write, okay, since A and B are two unit vectors, so that means sum of this two will be mod of the sum of their various sum of this two vector is root 2, because these two are unit vector also, and difference, the magnitude of the difference of this two vector is root 2. Okay, so here mod of vector A and vector B, I mean the mod of the sum vector is equals to mod of the difference of these two vectors. So it doesn't imply that the magnitude of sum of two unit vector is greater than the magnitude of their difference, because we can see they are same. So also statement 3 is false, right? So here we can say which of the above statements are not correct? 1, 2, 3. Option D is the correct answer.